Okay, again, welcome everybody. This is the first day of a two-part workshop. Today we want to introduce a number of the earthquake simulation tools that the SimCenter has been working on. And we invited folks here because we know you're kind of working in this space, and we want to kind of introduce these tools through some examples and give you some problems to kind of motivate that you could work on a little bit to learn more about the tools. To see how they could be applied in your research and teaching. And I mentioned teaching just because a number of us have found, say in our graduate classes, that over the last couple of years that we've started to introduce some of these tools for small modules that we use in teaching. I'm just going to do a brief introduction and get to the agenda and then turn it over to others on the SimCenter team. Just as a bit of background on SimCenter's approach to developing software, we recognize that there's a lot of software modules out there, and we're trying to cover kind of a large spectrum. If you look at these puzzle pieces here, from if you think of something like a regional simulation, describing the assets and hazards, simulating response, and going through to estimating damage, and even anticipating future work on simulating recovery. So it's a broad spectrum, and there's a lot of software out there. So our approach is not to reinvent the software, but rather to take software that's out there and kind of attach kind of pre and post processing to really streamline data flow from one part of the simulation into another part of the simulation. And we've taken a number of software modules and built them into the SimCenter workflow. As researchers, if they have other types of simulation tools that they are using or they are developing and want to plug them into the workflow, we're eager to kind of work with those folks to help develop the connections, the pre and post processor, to connect them into our workflow. So currently, this is sort of a complicated picture, but if we just look at this middle segment that I just highlighted, there's a lot of these kind of software modules that do different components of the process. These might be some small Python routines that we've written, or they might be other software modules that we encapsulate. Some of these routines may tap into external databases, which are shown at the bottom of the screen here. But the idea is we have these software components that we can mix and match into computational workflows. Now, to facilitate the use, especially as folks are getting kind of introduced to this, or for more routine uses, we've created a number of desktop applications, and that's what we're going to kind of focus on today, is to talk about a few of those that tap into some of these underlying components here. But I would emphasize too, for kind of power research users, if you like, that if there's features that the desktop applications don't currently tackle, we have the option of going back in through say Python coding and stitch together these components in other ways to tackle specific aspects of problems. So in terms of workflow applications, there's kind of a tiered set going from the top left down to the bottom. Something we'll talk about today is QuoFem, which kind of combines finite element type modeling, simulation modeling, with tools to quantify uncertainties, which is a big part of that hazards engineering. The next tier, the three tools that you see there, these are kind of taking the capabilities of QuoFem and connecting it with the hazards. Today we'll be talking about earthquake hazards, so in particular connecting it into characterizing seismic hazard and pulling in ground motions to facilitate that part of the process, looking at structural and geotechnical systems. Next, going down, is performance-based engineering. This is where you could take the output from the EEUQ, that is engineering demand parameters, and PBE has a backend called Pelican with kind of functions there that relate the demand parameters into damage functions and then costs. And finally, the RDT tool down below is really taking the first tools that I mentioned so far are ones that are really geared toward looking at individual kind of facilities or components. The R2D, actually I had to update this slide, is really taking all of these things and putting them into a regional setting. Now, we have a really ambitious agenda for today. For the first 20 minutes, we actually want to take you through three of the tools, the EEUQ, QuoFem, and PBE. And we're going to introduce this not by explaining all the details of the tools, but just by quickly showing just one example from each of the applications that you can tackle with it. So the first one's going to be looking at pulling in ground motions for a structural response. with COFEM, we're going to look at a geotechnical problem simulating soil effects. And then when we look at PBE, that'll be a performance-based assessment of a building. We're going to then spend the bulk of the time, about an hour, looking at the R2D tool, first kind of introducing it with some basic features, looking at an application study that we've done in the city of Alameda. And then in the second part of that, from 1:55 to 2:25, if you're in California time, is to dig a little bit deeper into that. In Alameda Island, if you know it, as geotechnical issues from liquefaction, then to look more carefully at site characterization and how you could pull that into the R2D and tackle that with Alameda. Then we're going to wrap up, and at the end of today and looking ahead to day 2 that we'll have in a couple of weeks, we want to, from each of the examples that you see, the first 3 in EEQ, COFEM, and PBE, and then the R2D, we've put together examples and we've posted these online where we really like everybody to at least tackle one of those in the area that interests you most, or maybe one of them from the first suite and then looking at the R2D, going through the step-by-step examples. They sound a lot like homework problems you might do in a class, but we want to try to kind of lead you through those. And if you have questions in the interim between now and day 2, we're happy to kind of address those. And then we'd also like to hear at the end, part 2, looking ahead to the next time we meet, is to hear from everybody here proposals of what you envision you could do with SimCenter software tools. So we'll talk a little bit about that at the end of today. But first, we're going to start out by looking at these 3 applications, and we apologize in advance. These are going to be really quick kind of fire hose delivery of what these applications can do. But we really think the learning is going to happen by kind of these examples that we've assigned, where you could download these applications and run these on your own. And I think that's where kind of a lot of the learning will happen. So I'm going to kind of end there and just briefly stop sharing for a minute.